Hello everyone. Today we will take you on a tour of a 3-ton-per-hour fluidized-bed boiler firing rice husk manufactured by DIVI Group. This 3 TPH rice husk fired boiler is installed at Phan Vu Concrete Factory in Long An Province. What you are seeing now is the fuel combustion process inside the furnace. The continuous mixing between the fuel and the fluidized bed material creates a very intense combustion, as you can observe. Due to limited factory space, the boiler was positioned slightly outside the doorway, which makes the access route appear somewhat narrow. Now let us move inside the boiler area. The first equipment you see is the fuel conveyor. This conveyor is responsible for transporting rice husk from the fuel storage warehouse to the intermediate feed hopper before the fuel is fed into the boiler furnace. At the moment, I am filming from the top of the combustion chamber. We will move to the opposite side. See the workers replacing the ash layer on the grate surface and pushing it down into the furnace. Now let us observe the inside of the furnace. This is the fluidization and combustion process of the fuel. The flame is very bright, and you can clearly see that the fuel particles are being continuously mixed and agitated. Fuel particles that are not fully burned remain heavier, so they stay in the combustion zone and continue to fluidize. Once they are sufficiently burned and become lighter, they are carried upward by the gas flow. Notably, this fluidized bed boiler does not use sand. Instead, it uses rice husk ash itself as the fluidizing bed material. This is a key difference of DIVI's boiler design compared to many other boilers on the market. This is the ash recirculation hopper. Coarse ash is collected here and discharged through a rotary valve system. Below the rotary valve is an ash collection bag, which allows sealed discharge without air leakage or dust emission. Below the rotary valve is an ash collection bag, which allows sealed discharge without air leakage or dust emission. By observing the discharged ash, you can see that the percentage of black, unburned particles is very low, with the majority being white ash. When the boiler operates stably over a long period, black particles are almost completely eliminated. Now let us move to the rear section of the boiler. Here you can see the hopper of the economizer at the front and the hopper of the cyclone dust collection system at the rear. The cyclone system consists of multiple small cyclones assembled together, increasing the dust collection efficiency to approximately 85%. The captured ash is discharged into the hopper, passes through 2 rotary valves and a screw conveyor, and is then collected for bagging. This is the wet dust collection system using a Venturi scrubber. Nearly 100% of the remaining fine dust particles are captured at this stage. Next to it is the scrubber water spray pump and the wastewater treatment area, which includes pumps, chemicals, salts, and sludge. All wastewater treatment components are centralized in this area. Now let us go up to the upper section of the boiler. The stairway is designed with a maximum step height of 250 millimeters and a slope not exceeding 56 degrees, ensuring safe and convenient access for operators. This is the water level measurement system. The black float is used to control the boiler feed water pump. Next to it are two water gauge glasses, allowing cross-checking to ensure accurate level indication. Above them is the water level switch, which provides boiler safety protection. This is the front top section of the boiler. At the rear is the tube cleaning access door. By simply opening this door, the heat exchange tubes can be cleaned easily, making maintenance very convenient. This is the flue-gas outlet duct. The flue gas from the boiler passes through the economizer, which recovers waste heat to preheat the feed water, thereby improving overall boiler efficiency. All required locations are equipped with spacious operating platforms, making inspection and maintenance easy. The boiler exhaust gas is mainly light white in color, which is primarily water vapor. From a distance, it is almost invisible and only becomes noticeable when zoomed in closely. Now let us take a look at the boiler control panel. The control cabinet uses a double-layer door design. The outer layer is a protective glass door, while the inner layer contains indicator lights and alarm push buttons. At the top is the HMI touchscreen, supporting both manual and automatic control modes. All operating parameters can be entered directly on the screen. On the left side are the three-phase power meters, indicating the electrical supply status. Below are variable frequency drives, VFDs for fans, screw conveyors, and rotary valves, which help reduce power consumption. The maximum electrical consumption is about 3 kilowatts, with an average of approximately 2.6 kilowatt. The PLC serves as the central control unit, managing the entire system. This concludes the overview of the boiler control system. Thank you for watching. If you have any demand for industrial steam supply, please remember to subscribe to the channel for more useful information.